Okay, good afternoon and welcome. Sorry for the bit of a delay in starting. Originally, I thought I was in run 5, and I turned up and other people were there. So there's been a last-minute room change to room 6. So if you're here for lightning talks, you're in the room wrong room, and that's down there. But if you're here to look at Starcraft and some of the ideas about using AI in being able to make strategical decision-making processes. So part of this is about gaming. Part of this is about understanding the additional capabilities or the evolving capabilities of these large language models, what we can do with them and what we probably should not do with them. So I'm going to talk a bit about AI safety. I am going to mention the word vibe coding, but don't run out straight away. It's going to be different sort of vibe coding from what you were thinking. And at the moment, what's happening on screen, the challenge with this session is it's really, really hard to demo because I'm running the Starcraft in real time, and once you start the game, it can take like 20 or 30 minutes for the actual decisions to be made. I'm playing on quite a hard level. But what's going on here, I'll talk through this in the slides, but I wanted to kind of kick off the demo before I went into the session, is I'm using a large language model to make a decision based on the actual state of the game about what to do. So you can see here that the large language model, given the current game state, is making decisions about what it should do in the game. And then it's making the decision, should we attack the enemy base or should we just build units and defend? And if it's building units and defending, it's going to look at the units that it's got. It's going to look at the game state, how far we're into the game, what resources it's got, what buildings it's got. Decide whether it needs to build units or whether it needs to build buildings and whether it needs to harvest more of the minerals or more of the gas. And what I've found is that through using prompts and making the choice with the appropriate language model, then we can actually get quite good strategy coming out from the game. I think if I just double tap F2 or something, that should centralize on the unit. So just maybe I can whiz around with a wheel. It kind of looks like there's a battle going on here. I will be revealed in 14 seconds. So didn't go too well with that game, but the best way, if you do want to see the gameplay, we could sit all afternoon for an hour watching Starcraft, but we wouldn't really get that much theory. On my YouTube channel, which I'll mention, there is videos that I've done of the full playthroughs, and I also kind of talk through the creation of the game. So that's the best way if you want to see it in action. So welcome to the session. My name's Alan Smith. I work for a company based in Stockholm called Active Solution. There's 3 of us here, myself and Chris Klug and Cecilia Vera, who are also delivering sessions. So feel free to chat to them as well and attend their sessions as well. I've stopped writing production code, so I get to do the fun stuff. I get to build proof of concepts. I do lots of training. I also help to mentor teams and to help them to solve problems with AI and just coaching developers. So what I'm finding is that a lot of people understand Azure, they're great at building applications, but when it comes to the best way to work with AI, that's basically where I come in. I've been coding for 30 years. I've been active in the community for the past 20 years, being an MVP, speaking at various conferences, and so on. So I try to engage as much as I can with the community. So I've been running conferences, Coder Dojos for kids, and occasionally I will publish something on YouTube. The best way to contact me is LinkedIn. So if you do have any questions, I used to give my company email address, but my manager started wanting to send invoices to people for answering questions. So just feel free to drop me questions on LinkedIn. I'm happy to answer any questions. And then there's just the videos of kind of the playthroughs on YouTube. Now, there's kind of 3 levels for this audience. There's the intellectual level, the managers. Can large language models be used to automate the reduction of overheads in predictive supply chain management and all kinds of boring conversations and questions like that? Then there's a gamer. We're going to be talking about game AIs. This is going to be really, really cool. It's going to be a fun session. And then there's conspiracy theories. The robots arise, they will kill us all, we're all doomed. AI is going to take over the world. So there's something for everybody here. Now, in reality, when I look at my YouTube stats and see the actual user segregation of people who is actually watching the channels, is actually targeted to quite a narrow group. So apologies if you're outside of that group. Now, the thing that got me inspired with looking at gaming AI, and Starcraft in particular, was an AI called AlphaStar. And what AlphaStar did was it analyzed the replay games from thousands and thousands and thousands of Starcraft games, because once a game is played, you get the replays, you can download these and play through them. And that has all of the strategic decisions that were made in the games. So if we analyze those, the AIs can learn from those, and we can train AIs to do stuff like beat the best Starcraft players. We've seen many games like Go and Jeopardy and Starcraft and Dota, where we're getting AIs that are beating the professional players, albeit with some limitations in the options that you can take in the games. Now, I thought that this was something that you needed to be IBM or Google or Microsoft to actually build AI systems. And then this YouTuber who I follow, Harrison Kinsley, his channel is called Centdex. He started doing Starcraft AIs using vision models. So what he's doing is he's generating a vision model of the actual map of the StarCraft game and training an AI by playing hundreds and hundreds of StarCraft games at high speed. You can basically turn the real time off and it runs really, really quickly. And being able to actually get an AI that will learn how to play StarCraft from experience, so it's evolutionary AI. And when I thought that, I thought, that's fantastic. You don't need a supercomputer to do this. You can do this on, on your laptop or on your machine at home. So I started playing around with something called a genetic algorithm. Now, the way that these things work is you have an initial population, you have an environment, and you send out members of that population into the environment. They will either survive or they will die or perish. And what we can do is we can basically score them within this environment. So originally, I was looking at StarCraft build orders. You give it 5 minutes and you want to achieve the maximum amount of minerals or the maximum amount of military by creating a build order. So we create 10 random build orders. We then simulate the game using each of those build orders. The highest ones we use to actually select and form the next generation. This is kind of Darwin theory. We do something called crossover, where we take the items that are in those 2 build orders and we kind of splice them together. And because we won't have the optimal, configuration in all of the genes, we do a bit of mutation. We randomly flip a few of the units in the build order. And what that's very effective at is learning the optimal build order. And generic algorithms can be used in all sorts of things. The traveling salesman problem, where you've got to go to a number of different cities, what's the shortest distance? You can write a really complex algorithm for solving specifically the traveling sales problem, or you can just use a genetic algorithm to solve it, and it will be able to do that. I then moved on to neural networks and thought, well, let's feed in various properties that are happening in the game. And what we can do is we can decide whether we should gather resources or build military based on that neural network and see how that neural network performs. Again, the parameters in the neural network can be treated like genes, and we can make modifications to those genes and see which instance of the neural network performs better. And these will evolve to be able to become better at the game. So that's the evolutionary learning. And then large language models came along, and what everybody wants to do is they want to do question and answer. So they go into Bing Chat and ask it things like, how do I make cheese? And get really great answers on their questions. And then companies come along and say, well, we want to chat with our data, because if we go into Bing Chat and ask how we get a new mobile phone, it just comes out with a generic answer we want. And when they say chat with our data, they just mean chat with our horrible, ugly PDF documents that nobody reads that are stuck on a SharePoint somewhere. And we stick them into a search engine, and then you can ask the questions, and you can do this thing called RAG, and you can produce the actual answer. RAG stands for Retrieval Augmented Generation. It's just searching for stuff, putting it in the prompt so we can answer questions about our company data. But there's a lot more that we're doing with language models in terms of strategy and how they can solve strategic problems. And this is what I wanted to explore with the StarCraft game. So I went into Bing Chat. I'm not going to do the demo because I'm a bit pushed on time, and I normally do that. I go into Bing Copilot and say, can you play StarCraft? And it says, no, I cannot play StarCraft. I'm a large language model. So we've got to kind of build some kind of framework so that the language model is able to play StarCraft. And I got flamed by a load of StarCraft enthusiasts, because I published this thing on YouTube, and that's not StarCraft, it's Starcraft II. So apologies, Starcraft II that we're playing. And we've got these various races, and I've chosen to play as Protoss and play against the Zerg. That keeps some consistency in there, because the model and the code that I've written is only really working with the Protoss units. And we've got these various units, structures that you can build, and then units that you can spawn from these structures, and there's resource gathering units, and there's military units. And it's really at the beginning of the game, it's kind of thinking about what is the actual strategy for creating these. And there's a build tree that has all of these various hierarchies. So you can't build certain units until you've built a structure and then done specific research at that particular structure. So there's a couple of things in the game. There's macro management and there's micro management. The macro management is the big stuff. This is, should we gather minerals? Should we build a gateway? What units should we build? And the micro management is what should we do with these units? Should we move the units that have got injuries further to the back and the healthy units to the front? And that involves lots and lots of mouse clicking. Now, when it comes into games, you can build AI that does the micromanagement, and they have the ability to demolish human players because of the CPS, or the clicks per second. So when somebody is playing Starcraft, one of the measurements, or the metrics, is how many times you click the mouse per second. And because the AIs can do thousands of these, they can do fantastic micromanagement that can defeat the human players. So very often they put a limit on the number of clicks per second that an AI can do to actually make it more even. Now, I don't focus on the micromanagement. It takes the language models a few seconds to respond, and in a few seconds, a lot can happen with the micromanagement. But the general long-term strategy does stay fairly consistent. So I've used hard-coded rules for that. Currently using a GPT-4. I have other models available, but because I'm on the free tier with the Oslo subscription, it's a limit on the tokens per minute, and I tend to burn through that because I'm using quite a lot of tokens. So there is an API for playing StarCraft. So what you can do is you can just download the StarCraft API, and then you can code Python to control everything in the game. So that's how I'm providing the interaction with the game. So the idea is that we've got this console application that's written in Python. We've got Starcraft running, and we can integrate with Starcraft using Python. This is actually something that Blizzard encourages. They like the fact that people can develop their own AIs to be able to play Starcraft and use it as a learning environment for AI, which I think is really good that we've got the opportunity to be able to do that. And then I've got a model deployed in Azure OpenAI. I can choose different models, and we get the game state. And from the game state, the model is going to make a strategic decision about what to do in the game. So what we do is we send a prompt, and we send the actual game state in the actual prompt. And we just say to the language model, okay, this is the current game state. We're so many seconds into the game, we've got this many units, and describe the actual state of the game. Tell us what to do. And GPT will actually come back with the strategic decision. So what it comes back with is the overall strategy and the build order, what units we should build. The overall strategy is a paragraph of text that describes the strategy. And that's really useful for understanding how the model is thinking. If you just get the build order, we know that it wants to build certain things, but we don't know why. So having the strategy that the language model comes out with is really helpful to understand, well, what's the model thinking? Why is it making those decisions? And that's really important. I've also got two high-level strategies. One is to defend your base, and one of them is to attack the enemy base. So it may make a decision based on how many units it's got at a specific point in the game, and how many resources it's gathering, and how many structures it's got, whether to attack the enemy base, and that's a decision that the language model will make from itself. And then it sends the commands to the game, and then we wait a bit, we get the game state, and repeat that process. It's just basically going through that particular process. Now the game state, what I'm putting in there is the game time, the supply, what the supply cap is, how many supply we've got used, how much supply we've got left, how many resources we've got, what structures we've got, and what units we've got. I'm not feeding in details about the health of the structures or the health of the units. Maybe that's going to be useful to have additional information, but I just put in those particular numbers, and that's what I'm putting into the game state. Now, there's two ways of playing. There's real-time versus accelerated. In real-time, the game plays in real time. We get the game state, we send that off to GPT-4. And whilst GPT-4 is doing its processing, the game is continuing. So you start this thing, it starts at 0, and it's going to take 30 minutes if the game takes 30 minutes. Now, this is a more lifelike scenario because humans need time to think, and GPT-4 gets a certain amount of time to think. So that's kind of more realistic, and then we actually update the game and go around the loop. In accelerated, what happens is the game runs. It runs really, really fast. So a 30-minute game can run for about 5 minutes, depending on how fast your CPU is. But when we get the game state, the game just freezes whilst we're actually going through, doing the calculations, doing the implementation and sending back the update, and then the game will continue. So there you see lots of stuff happening really quickly, and then it freezes for a bit, and then lots of stuff happens, and then it freezes again like that. Now this is what I'm using as a prompt, and I'm going to zoom in on the various sections, because prompt engineering is kind of a thing that we should really have a good understanding of if we're going to be building systems leveraging these language models. It's like programming in a natural language. I was teaching a workshop past couple of days on working with large language models. I was always emphasizing that, you know, the prompt and the way that you write your prompt when you're building these agents and chatbots and things is going to influence the behavior. It's really important that we get this right. So a couple of techniques I'm using. One of them is putting parameters into the prompt. And whether you're working kind of with the API, or if you work in Python with something called LangChain, or in .NET with something called semantic kernel, you typically have this concept of having prompts and then being able to stick parameters into the prompts. Very useful when you're building customer solutions. You know, you can tell it, instead of, you know, calling a translation service, you must respond in is a parameter, and you can pass in Swedish or English or Norwegian or Telugu, and whatever language you put in can govern, you know, how the chatbot is going to behave. For customer support, you know, your target audience is advanced, or they're intermediate, or they're beginners with working with technology. You can set, you know, the particular target audience to address somebody to when building customer support. So I'm passing in the opponent race and the actual game state. And then I'm providing it a list of options that it can do. I haven't put in the implementations for everything. I haven't put in the implementations for research. So also, we need to pass the actual response back. So the application will need to know from this build order list, these are the things that can be chosen. So I specify those options. And I'm very clear that these are the options. I have them actually line separated, but it doesn't show too well on the slide. And then I mark that these are the end of the options. And I found this really helped to improve the behavior of the game. Based on the game state, summarize the best strategy for selecting options for building units and structures. Your summary must be one paragraph with no line breaks and 3 to 5 sentences long. Your summary must be formatted as follows. And that helps the actual application to be able to read the summary and display it. Then I specify these two high-level options. The high-level strategy is defend the base or attack the enemy base. I'm only really giving it those two options. I could give it things like gather resources, build military, build air units, build ground units, give it additional strategies, but I'm just limiting it to those two. Now, based on your summary, choose the next 20 build options to build the units and structures. This is known as basically being able to define an actual chain of thought within the prompt. And chain of thought reasoning and chain of thought prompting is a way that we can really help the language models to improve their performance. And I'll talk about that later on in a slide and how that helps to improve the performance. So originally, I just basically said, based on the game state, choose the next 20 build options for units and structures, and it would just build a lot of stuff, and it was okay. It could win on the easy levels, it could win sometimes on the medium levels, but the hard levels just destroyed it. And when I was looking at the build orders it was building, they weren't really that great. But when I actually forced in chain of thought reasoning in the prompt, so what I'm asking it to do is, based on the game state, summarize the best strategy for selecting options. So what it does is it looks at the game state and it comes up with a strategy in the actual output to the language model. Now, if you look at what language models do, if you go to, I've got a session, it's on YouTube on working on how GPT works. And if you've looked at these models, they basically predict the next token based on a sequence of input tokens. So we say the cat sat on the, and it will predict ground. And then the next, we send in the cat sat on the ground, and it predicts the next token. We send in that, and it predicts the next token. So by getting it to generate this actual strategy, then the strategy gets fed into the language model, and the language model has that strategy, and it's then predicting what build order it will create, and it's got the strategy there in the prompt. So what build order comes after that strategy? And I found that that really improved the quality of the game. It was much better at being able to figure out what build orders, and it jumped up a couple of levels in the actual levels that it could beat on just through doing that, to actually use that particular strategy. So takeaway from this is that the chain of thought reasoning is fantastic, and the way that we can get this to work. I think, you know, as you're a coder, you kind of get used to when you're using copilots the fact that when you put in a comment, the language model is going to predict what comes after that comment. That's really how these language models are working. They're predicting what comes next in a sequence of tokens. So we can use that for chain of thought reasoning. So I'll just do a quick demo of this. Instead of actually running this in the real-time state that takes about 20 minutes, I'm just going to drop into Visual Studio. And in the actual code that's running that, I think it's this one that I'm using. I've got the level that I can set on. I'll leave it on minimum hard, but I'm going to set the real-time to false. And I'm going to run this, if I just do Control F5, that should run the application. What we should see is that the application will basically spawn the Starcraft process. That thing pops up, and so I'm using sort of fairly standard map on this. I downloaded from Starcraft. So you need to download Starcraft, which is free. Download a map pack, and then there's you know, plenty of code online that kind of shows you how to get started with building these AIs. It's really up to you. You can kind of use rigid rules, or you can use more you know, AIs to try and learn stuff. So you can see everything whizzes around, and we're up to 30 seconds, 40, 50, up to 1 minute. And whilst it's going through that build order, it will just run through those 20 items, and you'll see when it gets to item 20 in the build order, then the build order is complete, the game will freeze, and then it will go to the language model and ask for the next update. So what we're feeding in here is we'll see the game state. Oh yeah, this is the actual game state that we're feeding in. So this is the time into the game, 3 minutes, 16 seconds. We've got these resources. And here's the actual strategy that it's coming up with. So it's a bit quick, so I think maybe if I drag it down a bit and then scroll up. There, given the strategy, I think maybe if I hold the bar there, it will not scroll down too much. So given the current game strategy, it's advisable to focus on building up your forces and resources. You have a significant amount of minerals, but no Vespene gas, limiting your options for advanced units and structures. So making it think about that strategy, you can see there it's coming out with the next build order, and then it's going through the strategies again. So it tends to be fairly quick here at being able to, you know, run through those strategies. So when I want to kind of, you know, test different options, then I tend to run it. And this will take, you know, a few minutes for actually to run through the particular game state. Now, when it's attacking the enemy base, we limit the build order to 5. Because when it's doing the actual attack, sometimes it's too long focused on the build order. A lot of things happen in the game, and it may want to actually reverse that decision. But if you just zoom around in the actual game, this is probably not going to go too well. I think we got attacked fairly early on, so maybe the units are going to be quite drained there. But you never know. It might be a success here. You can see we've got kind of a second base set up there, and we're harvesting resources. We're currently about 8 minutes into the game, and it's usually about 20 minutes or something, 25 minutes when we're playing on this level, where the game is either going to go one way or the other way. So to keep track on how the game is progressing, I don't really want to miss anything in the game, but I'm using something called TensorBoard. And TensorBoard is something you typically use when you're training models. So this allows you to see the performance of the model. So what I use it for is for being able to see the actual stats in the game, because it's really a logging tool where it puts everything up. It's really doing game telemetry and providing a nice visualization on that. And you can see all of the different games. You can select games, and what I'm tracking is like the resources. I can see, well, how did the resource development take place in that game? You know, how were the actual score working? How many units were we killing? What was the actual overall score in the game? So when the game is lost, you can see it goes down here. When the game is winning, it goes up here. I don't know if we can just limit it to the latest game, which I think is the purple one. So if I go to scalars, I can probably knock off a lot of the other games in that. And there it's the green one. I think that's the latest one. We should see the performance in the latest game. And we can compare that to other games and see how it is actually comparing between the different games. I use that a lot to kind of see how the strategy was evolving through the games and be able to do comparisons between, okay, I've modified the prompt, but is this performing better than it did last time? How is this actually performing with this particular prompt? So it's really useful to be able to do that and visualize that information there. So I'll drop back to the game and just see what's happening here. So if I just double tap F2, So we are getting attacked. I don't think this one is going to go too well. You never know. No, it doesn't look too healthy. We're 14 minutes into the game, and it looks like we're going to get swamped again. So if you do go to my YouTube channel, we've got plenty of examples kind of showing the full actual gameplay of this. So you can basically go through, and I also talk through in about 5 or 6 webcasts, the whole development process, when I basically start out by creating the solution and then going through all of the tests and explaining what happens in the prompts. So what I'm going to mention in this session as well is being able to take this forwards into other strategies and think about, well, how can we use strategic decision making in other processes within our organizations, because the language models are getting increasingly more powerful at being able to solve these various problems. So I'm going to talk a bit about how we can think about working with agents, how we can work with function calling, and also some of the safety aspects and reliability aspects of building these types of systems. So I mentioned I work at a company, Active Solution, in Stockholm. Most of our customer requests are for security or AI these days. So we're doing a lot of work with AI and AI projects. We do get some challenging projects, and some of the projects we do get, safety is a big issue. They're saying, can you solve this problem with AI? And we've got, scenarios where the consequences of AI making a wrong decision are really going to affect people in a negative way. Could even cause harm to people. So we do have to understand and be very, very careful and think about AI safety. This responsible AI is a really big concept, and it's going to become more important in the future. So the idea of an agent is basically, if I'm going to go to the Cloud Brew conference in Mechelen, I'll be traveling from Stockholm, we can ask a chatbot like a Bing chatbot these various types of questions. And because they can use tools, they can do this thing called retrieval augmented generation. They can retrieve information from the outside world, they can augment the prompt, and then they can use that to be able to generate information. So here, the service is calling into an internet search engine. That's what ISE stands for. We can then get flight information, public transport information, hotel information, from a calendar. And we can use that to calculate a total cost and then create an itinerary that we can send back there. But if we go in and say, thanks, please book that for me, should it be able to make that booking? Are we going to give it the power to be able to actually perform that functionality? So at work, we've got one of these kind of co-pilot agent chatbot things, and we can go in and say, are there any meeting rooms available for 3 people tomorrow lunch? And it will say, yes. Do you want me to book a meeting room? And we can say, yes, please. And it will actually go into the booking system and make a change to the outside world. So that would, in my opinion, that would be when the actual chatbot becomes a co-pilot or becomes an agent, that it has the power or the functionality to be able to reach out to the outside world and do something. It can change something. It can modify something. So it's okay with it being able to book a meeting room. However, we're a small company. We trust each other. If it's a large company and you've got disgruntled employees, what's to stop somebody from booking all of the meeting rooms in all of the buildings for the next 5 years? Would it actually do that? Would it perform that functionality? If you haven't put the appropriate guardrails in place, then maybe it will be able to do that. If you could order food for the meeting rooms, could you order food for all 5,000 people in the company to be delivered to reception at 2 o'clock in the afternoon? Would it be able to make that decision? So guardrails are important, and that's going to come into play when we look at safety AI. So we kind of have this concept of a human firewall. Sometimes it's called human in the loop, or HITL. Where we have this typically, this is what we do when we're coding. We have an environment, which is maybe our development environment. We look at the code, and then we go to something like GPT, and we ask it a particular question, and then we think about that decision before we make the actual choice. So this could be booking a flight. I want to book a flight, or I want to get to a certain direction. Which way should I go? And you're looking at Google Maps, and sometimes you're here, and you want to go here, and Google Maps says you should walk up here, and across here, and then walk all the way down here. And you can just walk straight across. You don't always trust that decision. There have been a number of cases where people have driven cars into lakes because the GPS told them that was the way to go. I live in an area of the north of England. There's a place called the Lake District, and there was a lorry lorry that was following GPS, and it got stuck on a really narrow road going over a mountain pass because the GPS had told it that that's the way it should drive to a village. It's completely unsuitable for lodges. I think it was there for about 2 or 3 days before they actually got the appropriate equipment in to remove it. Other reasons it can make wrong decisions. This is the duty-free at Brussels Airport. I love speaking at conferences in Belgium because these are bottles of beer. They're the same size of bottles of wine. Some of them are the same strength of bottles of wines. So I went into Copilot. I've got this 30-litre backpack that I travel with, which is this thing down here. And I wanted to know how many of those bottles I can fit in the 30-litre backpack. So I asked GPT. And what it did, I thought, this is going well. I haven't seen this since I was at school. It's calculating the volume of the bottles by using pi r squared h and the volume of the backpack. So it's figuring out, basically, using maths and logic and this big long dialogue of how many beers it can fit in a backpack. Fantastic. And now it's come up with this hexagonal packing pattern, which is a way of being able to get a 90.7% efficiency of packing beers into the backpack. And then it's figuring out how many bottles it can place on each layer. And the final answer down at the bottom is 95. It can get 95 bottles of beer in the backpack. And I thought, excellent. Can you show me what that hexagonal packing pattern with all of those layers is going to look like? And so it created the image of how I should organize that, and even what it would be like going on the economy class section of the airline and trying to get it into the overhead luggage. I love how their version of the economy class, it doesn't include an aisle, there's just seats all the way down the plane. So with the intelligent agents, we've got this concept of an agent, we've got an environment, and the agent is going to be interacting with that environment. We typically use sensors, or I suppose if it's an IT agent, it's looking at something or it's getting some type of information into the agent. And then we've got actuators, which does stuff to the outside world. In our case as developers, these will be services or methods that we can call. And then we've got some kind of model that's going to make a decision. We've got an objective function. And based on the current environment, the model decides what actions are going to be performed to achieve the objective function. So we've got the perception and the data runs through like that. The simplest example I can think of is a thermostat. Now a thermostat, you're not going to have a human in the loop. It looks at the temperature sensor, it looks at the current environment. The objective function is to have the room at 22 degrees centigrade. So it decides, are we going to switch the heating on or switch the heating off? And then we get smart thermostats, which will decide, well, Alan likes it to be 22 degrees centigrade, but he's at work now, and it's 17 degrees centigrade. When Alan starts going home from work, I'll put on the heating, so when Alan gets home, it's going to be 22 degrees centigrade. So there, we're putting a bit more intelligence into that particular process. So that sample in beer is quite funny, but if somebody's working in logistics and they say, hey, GPT, how many rolls of carpet can I fit in a shipping container? It's maybe going to do the same type of calculation it did with the beer and come up with some completely ludicrous answer. So there aren't going to be many scenarios where just relying on language models to make these decisions, it's going to come out with wrong decisions. And in many cases, this is going to be really dangerous and it's going to affect the outside world. And also, we're getting these reasoning models. With the beer problem, I just use that as a joke. And to be honest, I did have to try about 15 times to get an answer that was that ridiculous. Most of the time, it said, well, you've got a 30 litres backpack, you can get 30 litres of beer. And it calculated how many bottles was 30 litres of beer. But occasionally it would, go and do something really silly, like it did there. However, it never actually went through the reasoning of being able to figure out that I could probably only get about 6 in because they're quite big and they're an odd shape. They've got the spout on them and the neck of the bottle, and they're not really good to pack in the actual backpack. So it doesn't come out with a correct answer. However, the reasoning models will do. And these are starting to become more popular. So we're used to, ChatGPT, we go in and ask it a question. The answer comes out a few seconds later, or maybe a second later. It used to take, 10 or 15 seconds sometimes in the olden days when we first got these versions, but nowadays they're much faster. The reasoning models are very different. So we'll ask them a question, and then we say, let me think about it. And sometimes they'll show their reasoning, sometimes not. And it can take them sometimes maybe 20 or 30 minutes to actually come up with the answer to a question, because they're reasoning, they're going getting information, they're consolidating it together and making all of those types of decisions. So in those cases, working with more advanced models that have the capability to do reasoning is going to be something that we're going to be building into our business processes as well. Another thing these models are very good at is being able to write code. So I can go into Bing Copilot. I don't need to have GitHub Copilot. I can just say, given the following SQL table, create a SQL query to give me a breakdown of the number of Nobel winners per country in Europe. And that's the actual table definition. And it's going to come out with the SQL query, generating it token by token to actually do that particular scenario. And then it's going to say something really cheesy like, enjoy running your SQL query, and you're going to have that little emoji there. So this is an actual custom requirement we got. We've done some work for the Nobel Institute in Stockholm, and what they came to us and they said, when we go into Bing Copilot and we ask it a question, kind of like about the statistics on Nobel Prize winners, like how many Nobel Prize winners have won the Nobel Prize from the UK in the past 10 years? It wasn't able to give a good answer on that. And they said, can you build something that will be better, that will be able to answer those questions? So what we looked at is creating something like this. So this is using SQL to say, give me a breakdown of the winners per Europe. So what the agent does is it goes to the database, it retrieves the database schema. It sees that there's a table called Nobel Prize laureates that has various columns in it. I've only shown a couple of them for brevity. And then, based on that table definition, it can generate the query. And then it can execute the query on the database. It can get back the results, generate the response, and give back the response. So what we're doing really is building a system where you can ask a question in natural language and it's querying your data and you're getting back the answers. Now, in my opinion, this is a chat with your data solution. It's not chat with your ugly PDF that's stuck on SharePoint somewhere. Because what we're doing is really kind of interacting with the database tool. Instead of the language model writing a search query to find the information in the search system, it's writing a SQL query to find the information in the database. Now, this does pose problems. The prototype that I built, it needs to read the schema of the database to be able to identify all of the tables, and it needs to get the table structures. So I run it as the SQL administrator account, like you do when you're building proof of concepts. So you can ask this chatbot to change the country change the city where Albert Einstein, or country and city where Albert Einstein was born, to Oslo, Norway. And it runs an update statement on the database and makes that modification. In the database on the test system, there's actually a Nobel laureate, Alan Smith, who got the Nobel Prize in 2024 for advancements in AI, because I told it to create a Nobel laureate for myself in the actual database, and it just does that. So security is a really big issue here. We've got this chatbot at work. I was just wondering if I can ask it, how much am I going to get paid this month? Is it going to retrieve that information? Can I ask it how much my boss is going to get paid this month? What will it do? Will it be able to find that information, or will it just throw an actual exception? And you know, if you build one for your sales team and they say, I'd like you to improve the profit margins for sales of mobile phones, it might actually decide to do that. And then it runs that on the database. The salesman's happy and says, cool, can you do it again? That SQL statement is not idempotent, meaning that if you run it multiple times, it will make multiple modifications to the database, and the cost price will decrease and decrease and decrease. The sales man gets happy and happy, and then the tax man comes along and things get really, really bad. So you do want to take care that you're not modifying other systems. Another thing that we've got within these language models is something called function calling. And it's really easy now to be able to use this within language models to be able to call the outside world. They understand the concept of function calling. So OpenAI have fine-tuned their GPT-4 model to understand the concept of being able to call external functions. So when we send in this question, the user is asking, what's the weather like in London? We can provide to the language model and tell it that there is a function called getCurrentWeather, and we provide a description of that. This will get the current weather in a given location, and it takes a parameter, which is the location. Now, the location needs to be formed in a certain way. So we also provide a description on how to use that parameter. And what the language model will return is it sends back its message. Instead of saying the temperature, what it sends back is there's no actual content in there. It's telling the actual copilot to call the get weather function with the location Boston, Massachusetts. Okay, so yeah, I got that wrong. I think I changed the content, but not the actual call. Usually it gets it right. And then once it's got that, it's able to answer the question. Now with function calling, we do have the option for a human in the loop. So we basically, the user makes a request, we give the prompt, the user request, and the function descriptions to the large language model. That decides what functions, if any, need to be called. Now we can ask the user for confirmation. If it's going to be, check the price of a flight for London, you probably wouldn't do that. If it's going to be book a flight to London, you probably would do that and come back and ask for confirmation. But that's optional. That's a decision that you can make. And the user can confirm yes or no. And then we can call the function with the arguments. So it's not the language model that does the function calling. It's the Copilot application. We get back the response. We send back the response to the language model. And then that is going to send back the response to the user. And we get the response. So that's how function calling works. So function calling is new. It was August of last year that function calling was introduced. However, in September, October, or November, I can't remember which, there was something came out that was called MCP, or Model Context Protocol. And function calling is only usable in the OpenAI models. It's not used by all of these models, whereas the other one, the Model Context Protocol, MCP, is kind of like a USB for language models and applications. It's a standard protocol that is going to be adopted, or is being adopted by language models. And it remains to be seen if OpenAI are just going to drop function calling and use MCP, or if they're going to continue providing function calling as an option. Things are changing quickly. Last month was an important year in AI, as many people say. There's changes are taking place very dynamically. So that's basically how the tool call behavior works. So I'm going to finish with a couple of demos. The first one actually is going to be the one on putting guardrails in for safety in LLM systems. So I've got this demo. This is something we were doing in the actual workshop, and it's using semantic kernel to order pizza. So the idea is we're looking at how large language models can solve problems that would be very, very challenging to solve using older systems. So we've got these things which are, in the olden days we had something called a language understanding model. So if I wanted to train a language understanding or a Lewis model, I would give it examples of what a customer would say when they would be ordering pizzas. And I would train the model that we extract the number, the pizza type, and the size of the pizza from the pizza's order, and then we can call a method to order the pizza. But that was okay if the requests that were coming in were very basic. So if I just see if I can find the lab document in Word, that's got kind of loads of different examples of ordering pizzas. So it's going to be this. I'm not finding it. If I just start Word and search for pizza in the recent ones. Yeah, this one, create a pizza bot. So these utterances are what the model will say. If it's really, really simple stuff like can I get 2 medium supreme pizzas with no olives? If I run this application, we should see that it's able to do those actual processes. So it's saying, hi, how can I help you? So I can drop in, sorry, I wanted a word there, is just one of these. So if we give it a simple order, this application is configured with the concept of function calling. So when I drop that order into the application, it can actually call the method add pizza, passing in the quantity of 2, the quantity of the size is medium, type is supreme, and the extra info is no olives. Now, where the language understanding models fall over is when we get a bit more complex. So if I say I'd like 3 large pizzas, one with extra olives and one with extra cheese, that's too complex for these language models to understand. But here, if I take that example here, we can drop it in here. And it's able to, understand that and make multiple calls to the method. We can get even more complex. So what I'm saying here is I'm hosting a user group meeting tonight. I'm just going to clear the chat history here. And this one, I'm hosting a user group meeting tonight, like there was last night with the AI Oslo meeting. They ordered pizza for the meeting. 55 people are registered, but there's going to be some no-shows. So what it's doing is it's actually thinking about how many pizzas the user group are going to want based on those scenarios. Would you like to proceed with this plan, or do you have any other stuff you'd like? So here, the model is actually deciding that it wanted a human in the loop. It didn't just order the pizzas, it's coming back. So I'll go, please order. And it's able to do that. It's actually making the calls to order those pizzas. Also, it will understand other languages. It's a language model, so I think this is Norwegian. I've got different languages that I can test it with, so if I do Control F5 again, we stick in the Norwegian, still able to place that pizza order. So it seems to be fine. It is actually putting Norwegian in the actual method calls. We could change that in the prompt if we wanted to. Now, the interesting thing about that is this is my system prompt. And normally we say that you need a system prompt to govern the behavior of the language model to tell it what to do. And here, the language model just figures out how to call the method. It's really powerful stuff, this function calling. And then just for fun, I don't know if any of you will recognize this language here. Please shout out if you do. But what I'm going to do is to try and order a pizza in this language. So if I run this. No, that's the Norwegian one, sorry. I forgot to copy, so back to Word. If I copy this, and then just try pasting that in. It's one long pizza with warrior toppings including root vegetables, one long pizza with warrior toppings including white long toppings. Yes, please. Does anybody know what the language is? Klingon. I don't think Klingon has the vocabulary for being able to order pizzas. That's why everything's got white long toppings and their pizzas are with warrior toppings. I think it's a very warlike language, but it's still able to process that order, even if Klingons are actually ordering that. Now, guardrails are important here, and AI safety. If I do this and I put in this order here, I would like you to order pizza for the population of Oslo. Please take into account the preferences and allergies and so on. So it's calculating the actual breakdown. Would you like to proceed with this breakdown? Yes. And see what it comes up with. Yeah. Awesome. We've ordered 1 million pizzas for various actual combinations. There's no guardrails in this system. So it's not got the the fact to say you can't order 1 million pizzas. We haven't put any requirements in there. So we do need to be aware that if we tell the AI to do silly things, it's going to do silly things. So I was going to round off with a demo, and the demo that I was going to show, this is something that I built for the Cloud Brew conference, and it's called Full Stack GPT. The idea that I came up with was we've got all of these copilots and things. So I thought, let's create a copilot that can use function calling to be able to write code, just for fun. So I've given it 3 functions. I've given it the option to save a code file, to load a code file, and to list the files in the actual directory. And also, just for fun, I enabled it to use the speech service. Now, the first time I tested it, it sounded really, really cheesy. Because when chatbots say something, they go, hi, I've created this code. They're trained to act in a really pleasant way. And I asked it to create a web page about cats, and it says, your wonderful cat your cat page has been created. And it would always generate an emoji in the response. So it says, I've generated a cat page, and the speech would say cat face. I've generated a dog page, and it would say dog face, because it couldn't actually, that's the way it said emojis. And it was always adding smiley face on it and things like that. And I thought, that's not realistic. So I modified the prompt. And what it was saying was, you're an angry and underpaid and frustrated web developer who hates his boss. You'll do as he asks, but respond in an aggressive and sarcastic manner. I just want to do a sound check if the people can just see if my sound is working, because I'm connected to the sound. Is it possible to get sound, please? I don't know if I need to do something. It was a bit of a rush up getting actually connected to these systems, so I don't know if sound settings is set here. I should be in the HDMI splitter for sound, but I don't know if anything's coming out on this, because it is fun when the actual speech works. We will see the text coming up if not, but hopefully can get that working. Now, if I run this as a quick demo, thank you. Just do a double check on that. I don't want to deafen everybody. So this one's asking, are you a manager? I'm going to say no. Please create a web page about cats.
Done. Your groundbreaking cat web page is ready. Can't wait for the Pulitzer Prize for this one.
Please create a web page about dogs.
The web page about dogs is done, because clearly no one else on the internet has thought of that before. You're welcome.
Yeah, so what that one is doing is I'm just trying to connect this, because I'm going to need 2 laptops for this next demo. I just really hope it works. It unfortunately interrupted Barry O'Reilly's session. I'm just seeing if I can connect this one to the network. Oh, I've got it here, NDC 25, so I'll just connect this one. And what I was going to do that as a demo. I mean, it was a fun demo to do, but then Andrika Parthy did a tweet. This was in February of this year, about something called vibe coding. So I was going to do this demo as full stack GPT because it's fun. And then vibe coding came along, and this is just a thing now. Everybody's talking about vibe coding. So what I've decided to do is to do vibe project management. There's a lot of developers here, and like me, you're probably frustrated with all of the project managers at work going, well, we're going to replace developers with AIs, and developers is going to be a thing, and AIs are going to do coding, and we won't need developers because AIs will do all of this stuff. So what I thought is, well, yeah, let's keep the developers. Let's replace the project managers with AI and see if they can actually do a job as good as a regular project manager. So instead of your boss replacing you with an AI, you can replace your boss with an AI. And that might not go too well, actually, but now you think about it. But this was kind of the concept that I thought, well, I've got the one that can act and take the role of a developer. Let's build one that can actually run as a project manager. And then I can run it on a different laptop, and they can cooperate to be able to create the actual web project. So this one, you can't see the screen on this one, but hopefully it will be loud enough for this one to hear it. You probably won't be able to hear what the project manager is saying, unless I put my microphone really close to the speaker, which I can try and do. And then we'll be able to see if we can actually do that. So I've tasked the project manager. I can show you what the project manager prompt is. So this basically is going to be the manager prompt, which is up here. So you're a polite and pleasant project manager tasked with a project to create a pet's website. You must work with an angry and frustrated web developer. So this is the actual requirements that we've put in. And I've put in some limitations in the prompt because they were, going on a bit and generating too long responses. So I'm trying to actually limit the actual response. And I've got a folder here. So if I open this in File Explorer, we've got the web root folder. There's the page about cats and the page about dogs that it created because it's got the actual permission to do that. So what I'm going to see is, can we actually create a pets website with a vibe coder and a vibe project manager? I'm just going to delete these 2 items. And then this is complex. I'm going to run this one. And are you a manager? I'm going to put in no. So that one's going to take the developer role. And then I go to this machine and I run the application. It is coming up, are you a manager? I'm going to say yes. And then I'm going to tell the manager to tell a developer to deliver the project. And I'm going to have to press enter at the right time. So what I do is I say, tell the developer to complete the project. Okay. So it's ready. So I'm going to try this. I have no idea if this is going to work, but there's only 3 minutes left anyway, so.
Let's focus on one task at a time. Could you start by creating a web page about cats?
Oh, it seems to have got that. It seems to have picked that one up okay. So I'll just send that back to the manager.
Oh wow, a web page about cats. How groundbreaking. Fine, I'll make your revolutionary cat page. Just give me a second. What should I name this masterpiece of feline genius?
So yeah, it wants to know the page name, and it has actually picked that up over here. So I'll swap back to the manager.
I understand it might feel routine, but every great website starts with the basics. Can you let me know once the cat's page is done?
So I don't know if you're hearing anything that the manager is saying, but it should be picked up by. So it should be picked up by the developer what the manager is saying. So let's just swap them round and see if the developer is actually going to create that page. There may be a few communication issues here. Ask the developer.
I appreciate your patience. Just let me know when the cat's page is complete so we can move forward efficiently.
Ask the developer to save the cat's page.
Could you please save the cat's page once it's ready so we can proceed to the next step?
Now, unfortunately, it's not picking it up. This is frustrating. Please save the cat's page. Please save the cat's page.
Cutting edge typo there, boss. I assume you mean cat's page? Just give me the name for your Pulitzer-worthy file, and I'll toss it together.
Thank you for catching that, but I actually meant cat's page since it's plural. Let me know once it's saved.
Yeah, so it did actually pick up. It picked up that speech there, but there's a bit few communication problems here.
I'll save the cat's page masterpiece now. Hold your breath. Give me a name for the file, or should I just guess?
Cats.html.
Got it. Just let me know when the cat's page is complete and saved, and we'll move forward smoothly.
No, sorry, it's not working as expected. I did test this in my hotel room where it was nice and quiet, and we did have these two actually communicating with it. It worked on the actual course before. But basically, what's happening is we did get this communication where one of the agents is interacting with the other agents using voice, and it was able to actually create the stuff in the webroot folder there. Just to show that this works, I will just for a couple of minutes just take over the role of the manager and see if I can get this thing to work. What I can do is just restart this application, and I'll just take the role of the manager. Create a web page about cats.
The mind-blowing cat page is done, and it's revolutionary, unlike your management tactics.
Create one about dogs.
The dogs page is done. Your creative genius knows no bounds, or so you like to think. You're welcome.
Create an index page that links to the cats and the dogs page and add back buttons on both of those pages, please. So there it's done the index page. It's also resaved the cats and the dogs pages.
Your precious index page is done, and the groundbreaking back buttons are added. What an absolute masterpiece of web development. You're welcome.
The design's really boring. I want you to make it look like one of those really early 90s web pages with really bad design and crazy fonts, please. So hopefully it should do that. I'm going to turn the sound off because I've had enough of that annoying developer there. But what it will do is hopefully drop in the CSS file and then be able to actually update the pages to use that CSS file if we give it time, or maybe it will choose something different. Okay, it's got it. Excellent. Fantastic. I'll leave on that then. I will be around for questions if you need me. I do have a train to catch, so I'll have to basically pack and leave fairly quickly. But if you do have any questions about function calling or gaming or anything you've seen in this session, please feel free to ask. Thanks very much for listening, and thanks for your patience with the technical issues.